Okay, today we're going to talk about the deluxe version of the crate rolling robot. My first version copied the tin toy that you can buy, and that the legs were just fixed in a walking type pose. As the crate rolled, it just drug the legs along. Wasn't really happy with that, but I wanted to come up with a simpler way to get the feet to move. So before I turn it on, maybe you can catch it better in the camera. As you can see now, as the robot moves, the feet move in a stepping motion. Actually lift up and down and step. So we'll still have the moving arms as the crate moves, and now we have the moving feet. Just turn it around this way. Oh baby, finally grabbed hold. So as you can see, basically the crate is just a square wheel. And we take our shaft off there's a gear motor in there. This comes off the shaft, which connects to the robot. And the thing that's going to make the feet move is I put a center wheel between the two with offset cams, and the legs are just freely there to move. The wheel itself is anchored in place by two long supports that go up to the body and a metal pin that gets put in there, so that when the wheel turns, the feet move. So, how do we do all that? Well, let's go ahead and move up here. Let's take a look at the Thingiverse, where I've got the STL files listed right now. We should be able to view some of that stuff. Zoom in a little bit maybe, huh? Okay, we don't need the picture. Let's move on and see what else they show us. Well, for example, here is a picture of one of the STL files for the leg. You can see the cam part would go in there. This part will fit up inside the body to keep the leg not sloppy, keep it lined up as it's moving up and down. Because the leg is just cosmetic, it isn't load bearing. There'd be the battery door plate for the crate. This is kind of an odd angle to view this at, but basically what you're seeing is the arms. You're seeing a right arm, a left arm, and then separate cosmetic pieces, which I've added to add a little more detail to bring the cuff out and put a little lightning bolt on there to make the arms look better. So that's one file for that. Here's some pictures that might help explain. The robot, obviously when it prints, the arms aren't part of it. The arms are separate. We just talked about that. But the whole robot body and head is printed in two parts. There's a seam where you glue the front and the back together. And these glue as well. They're seamed. These are the supports that we just talked about. That little wheel you saw rotating gets pinned between those two. How about the next picture? What comes up next? Well, here we are inside the crate. This particular time, the TT motor, I got the slow gear ratio, which is 120:1, just happened to be black. They're almost always a yellow-orange color. This time it was black. So it's screwed in with two 632 screws from the other side, which then we glue a cover that's similar to this battery door cover, except it has a hole over it. And I mount my switch there, a standard slide switch with about 19 millimeters between the mounting screws. I just glued in two AAA battery holders there. When you are looking at this side of it, here you can see this plate has been glued over it to hide the two mounting screws that are holding the motor in. You can see the switch here. When you're looking at the shaft from this way, it should be rotating clockwise if you're setting this thing up the same as I did mine. Another view waiting for the lid to be slid. And here's a picture of it before I decided to paint it. I printed everything in some yellow PLA just because I could buy it dirt cheap. It was the cheapest PLA I could find. And I knew I was going to be painting anyway. So here you can see how this cover piece, with the one with a hole, gets glued over this flat main crate piece. This is all one print, and normally this would be down on the bed of your printer. So the only place you need supports is for these countersunk screw holes. So I just, on my Prusa slicer, I just turn supports on build plate only, and it'll put supports just in those two screw holes, and everything else is support free, so it's much quicker to print. And there's the little motor, which I said this time, ended up being black for whatever reason. Here's the body halves again, and here I'm holding what we want to call the wheel cam assembly, and I'm holding an 1.5 inch long rod. In this case, I'm using 1/8 inch steel welding rod, which is about the same as 3mm rod. And it doesn't have to be steel. It's just that I have a bunch of old welding rod. You can go to the hobby store or buy online brass 1/8 inch or 3mm, and that should work just as well. When you do go to assemble this, though, there's a particular order that you do things in. One, you don't have the shaft in here first. Well, maybe I'm getting ahead of myself. This is printed in 2 parts, actually, so there wouldn't have to be any supports. And you glue this side to that side with the cams when you add a phase. And when you glue them, you'll want a shaft in there to make sure you got everything lined up right, and so it spins free. But when you actually go to assemble the toy, you'll take just this cam thing and insert it in one of the big holes on one leg, a big hole in the other leg. Then you'll push both legs up into the body. Then there'll be a small slot in the side of the foot, and if you rotate the wheel, you'll finally see it line up with the slot, and you can push the pin in. Once the pin's in, you can put a little drop of glue on the end of it to keep it from coming out. Let's see if there's some more pictures here of interest. This is the crank handle, this piece right here. It's designed to fit one of the TT motors. There's a particular size there. You can screw it on if you want. I press fit mine on, and so as not to break the motor when I press fit, I hold the motor on the inside and press from the outside to press it in. Then there's going to be this metal rod that goes into it, and here, and again, I'm using the 1/8 inch welding rod, so 3mm rod stock of your choice, and it's basically 2.5 inches by 2.5 inches with a bend. This one can actually be a little bit longer if you want. You want to make it 2 3/4, that's fine. And well, let's not get ahead of ourselves. So that's the crank. It prints in the orientation you see there, and again, I turn supports on for build plate only, so that this part in here that's hollowed out for this for the screw and everything doesn't get filled in. You just dig the supports out afterwards. Okay, it's an odd angle, but this is showing the wheel and cams. There's one of them there, one of them there. And this, if you print them that way, you don't have to use any supports. You can just glue the 2 pieces together, and then find an appropriate rubber O-ring to snap into the groove. There's the other leg. Here you can see the small hole for inserting the pin when you're assembling. And there's the crate lid with the hole. And there's the crate itself, which we'd already talked about. So, I don't think there's a whole lot more here that needs to be talked about. The robot itself is a remix from a guy on Thingiverse called Javo. And it was just called Vintage Toy Robot. And it's basically the 1950s R7 wind-up robot. He did a pretty good job on the design. The only real problem with it, if you just wanted to build it off his thing file, you won't be able to, because the way he laid the parts out on the STL, this foot is contacting the body and the back. They're touching. You can't separate those, so you can't build it and print it. So basically, I went in and chopped everything up into individual parts. When I got to the body, I had to split the body and then mirror the side I had there, put the 2 halves back together so I could get one clean body. And then, of course, I started with all my mods. I mean, I had to make major changes to the legs, hollow them, put the holes for the cams, add the extra flap for alignment, and on the body, do all the holes so the legs can fit up inside and all the slots and everything. A lot of changes. But I still liked his original design because it's a very classic robot, and I thought it'd be a good one to use for this. So you can always investigate him on Thingiverse. It looks like he's thing number 2759322. And the idea for the toy actually goes way back. There have been toys like this. Usually they've done drums. round instead of square. Sometimes they do balls where the whole thing is circular like a ball, and there'll usually be an animal on top of it, like a seal or an elephant or something. But there have been ones where there have been guys pushing them as well. So this particular toy can still be purchased. It's a tin toy. Tin Toy Arcade for about $32. You can get a wind-up version. But as you can see, it has the fixed legs in a walking position. I thought the toy idea was cool, but I thought it would be a whole lot cooler if the toy itself had moving legs. So that led to this design, so that the feet could actually walk as the crate moved. What else do I want to say? When you get ready to actually build and assemble this, there will be links down below for the Thingiverse files for it. The only alignment thing you're going to do when you glue the shaft into here, you want to make sure, just flip the arms back out of the way, you want to make sure that you don't push this in so far that the crate actually will hit the robot. You need a little bit of clearance between the two right there, see? So that'll help you tell you how far that's going to go in. And the other thing is, when the shaft comes through, you're going to want it lined up perpendicular with the crate. In other words, you're not going to want the crate twisted to the robot one way or the other. So you can just sight that when you get ready to put your super glue and shove the thing in there and get it squared up. Or you can just rotate the whole thing down to the table, and the crate will provide one flat surface and your shaft would provide the other. Then once that's glued, then you can worry about gluing the robot part on. And the whole trick behind that is when you're sitting on a point like this, that's going to be the highest point this way. So you'd want to make sure your toes aren't totally digging in. And when the crate is completely flat, I guess I said that backwards. When your crate is completely flat, this would be down low, so that would be your toe forward. You want to make sure that the wheel is still touching at that point and the toes don't jam it up. And when you're on the point one that we were just at, that would be as far back as you can get. So that'll tell you when you get the glue on that and you're shoving the shaft in, what kind of angle you want on your robot, so that you get the angle right so it works best. And as far as how far into the shaft goes, we just want the robot lined up with the shaft, because you want both the arms to be able to ride right on there when it's operating. Alright, the mouse will stop it, that's good. And of course you can always jam it for just a second or two to hit the switch to turn it off or on. I think that's about it for this build. Have fun, and if you make one, leave a comment down below.